Hello, welcome to Pragim Technologies. I'm Venkat. This is part 30, Introduction to Interfaces. In this session, we'll learn interface basics. In the next session, we'll talk about abstract classes and the differences between abstract classes and interfaces. After that, we will find out the real-time scenarios where we can actually use interfaces and abstract classes. These two are very important concepts and we use them a lot in live projects. All right, so and interfaces is one of my favorite subjects. All right, we know that we create a class using class keyword. So to create an interface, we use the interface keyword. And interfaces are very similar to classes. We know that a class can contain properties, methods, delegates, events. Similarly, an interface also can contain them, but only declarations and no implementations. So let's see what we mean by that. So to create an interface, we use the interface keyword. And let's say I want to create a customer interface. Look at that. Just before the customer name, I prefixed a capital letter I. This is a common naming convention. Okay, interfaces in general are prefixed with a capital letter I, the interface names I mean. Okay, now if you don't give that, we don't get a compiler error, but it is just a common convention. So if you look at that, we'll succeeded. Okay, so the reason why we do that is just by looking at the name, you can tell this is an interface and not a class. And if somebody is using that interface somewhere, let's say for example, iCustomer C1, okay, so just by looking at the name, you can say that, okay, this is an interface and not a class or a structure, you know. That's why we use the capital letter I in the name of the interface. Now, I told you interfaces can only contain declarations and no implementations. So for example, let's say I want to have a print method. So I'm saying void print. And then I close the method and a semicolon. You cannot have an implementation. Let's say for example, console.writeLine, hello. You cannot do this. Okay, if you try to do this, you will get a compiler error. So let's go ahead and build this. Okay, and we clearly says the error clearly says interface members cannot have definition or implementation. They need to only have declarations. So an interface member should only have the method declarations, property declarations, etc., but no implementations. Okay, so if you look at this interface, it has only declaration, the return type of the method, the name of the method, and then a semicolon without the curly braces and implementation. Okay, another important thing to keep in mind is that interface members, okay, this is an interface member, so interface members are public by default. Okay, and that does not mean you can use a public keyword like this. Okay, if you try to do that and when you try to build the solution, you get again a compiler error saying that the modifier public is not valid for this item. So interface members are public by default and you cannot have an explicit access modifier. We haven't spoken about access modifiers yet. We will be talking about them in a later session. But remember that on the interface members, you cannot have access modifiers. They are public by default. Okay, now can an interface have fields? No, we know that a class can have fields like int id, string name, etc. But an interface cannot have a field. So this is a field, an integer field. Now if I go ahead and try to build that again, we get a compiler error stating that interfaces cannot contain fields. So remember that as well. Okay, so we have this interface and this interface, let's say, can be implemented by a class. A class can inherit this interface. So let's say, for example, I have class customer and this class is inheriting iCustomer interface. Okay, so now this customer class is actually implementing this iCustomer interface. Okay, now when a class inherits an interface, that class has to provide implementation for this interface member. Okay, otherwise look at this, if it doesn't provide implementation and if somebody says customer C1 is equal to new customer And then when I say c1.print, c1.print, we basically, since this class is inheriting from this interface, this method is available to this class. And if this class doesn't provide implementation, the interface didn't provide implementation for this method. And if the class doesn't provide implementation for that method, then what will this line do? That's why any class implementing an interface member, it could be a method, property, event, whatever. If the class inherits that interface, it has to provide the implementation for that interface member. Otherwise, we get a compiler error. Okay, now let's go ahead and try to compile this. Let's get rid of these lines. If I try to build this, you will get a compiler error stating that customer does not implement interface member print, I customer.print. Okay, so the interface will only have declarations, and those interfaces are there for your classes or structures to implement, to provide implementation for those interfaces. You might be wondering, if the interfaces doesn't provide any implementation, then what is the use of these interfaces? Don't worry about that. We will actually talk about the real-time scenarios where we use these interfaces in a later session. But for now, let's understand the basics around interfaces, the rules around interfaces. Okay. All right, so this class has to provide the implementation for this interface member. So in order to do that, public, okay, we need to use the access modifier here, void, and then the name of the method. Now look at this, the signature of the method should exactly look similar to the method in the interface. For example, here I say, instead of the same signature, if I say name here, now this method is different from this. So the compiler doesn't treat as if you're implementing this print method here, because this print method signature is different. It has got a parameter here, but it doesn't have a parameter in the interface declaration. So if you try to build this, you will again get the same error. Okay, so that's why the signature of the method in the class should match the signature of the method in the interface. So now if we go ahead and compile, it will compile without any issues. So look at that, build succeeded in the status bar. Okay, so let's say for example console.writeLine, and we'll just put here interface print method. And then if somebody wants to create an instance of this class, what they can do is customer c1 is equal to new customer and c1 dot print. So if we go ahead and run that, interface print method. Okay, so let's go back to the slides. So we know that we create interfaces using the interface keyword. Just like classes, interfaces also contain properties, methods, delegates, events, but only declarations and no implementations. If you try to have an implementation for an interface member, it's a compile time error. It's a compile time error to provide implementation for any interface member. Interface members are public by default, and they don't allow explicit access modifiers. And interfaces cannot contain fields. We have seen that as well. If a class or a structure inherit from an interface, it must provide implementation for all interface members, otherwise we get a compiler error. In our example, this interface has just one method, and this class is implementing that interface, and it has to provide implementation for that method. If there is another method or a property or an event, your class still has to provide implementation for that member as well. Okay, so if a class implements an interface, it has to provide implementation for all the interface members. Otherwise, we get a compiler error. A class or a struct can inherit from more than one interface at the same time. Okay, this is another interesting and important concept. Classes allow multiple interface inheritance at the same time. For example, if I have another interface, let's say interface I2, and this has got maybe public I2 method, oops, void I2 method, something like that. Now this class can inherit from more than one interface at the same time. So this class can inherit from this interface as well. And look at this, To provide the implementation of this method, you don't have to type it by hand. Visual Studio will actually give you a snippet to do that. Implement interface I2. There's another option, explicitly implement interface I2. We'll be talking about explicit interface implementation in a later session, so don't worry about that. So implement interface I2. What's going to happen is it will automatically stub this method out in the class for you without you having to type that. Okay, so a little bit of time can be saved in terms of typing. So what we can do now is console.writeLine I2 method, just to know that. Okay, now look at this. Your class can inherit from multiple interfaces at the same time. That's possible. So if I go ahead and build that, it will happily build without any errors. But whereas we have seen in classes and inheritance that a class cannot inherit from more than one class at the same time. Now let's say you have this class called class customer. Let's create another class, maybe class sample, and will not provide any implementation. Okay, basically we have two classes. One is customer class and the other one is a sample class. Now, can my program class inherit from both of these classes at the same time? Let's see that. Customer, and then I'm saying sample. Okay, so this class is basically trying to inherit from customer and sample at the same time. Let's go ahead and build and see what's going to happen. We get a compiler error. Base class customer is less accessible. Okay, that is because of missing access modifier. Let's put that there. Let's put this here as well. We'll come back to access modifiers in a later session. So let's go build the solution. So class program cannot have multiple base classes, customer and sample. It's not possible. A class cannot inherit from multiple classes at the same time, but whereas a class can inherit from multiple interfaces at the same time. So multiple class inheritance is possible, it's not possible, whereas multiple interface inheritance is possible. Okay. So interfaces can inherit from other interfaces. A class that inherits this interface must provide implementation for all interface members in the entire interface inheritance chain. Let's understand what we mean by that. Okay, let's get rid of these things here. All right. So let's say I have two interfaces. This is one interface. Let's call this as iCustomer. And let's call this, we have one interface called iCustomer which has got print method, and let's call this iCustomer1, and let's call this iCustomer2. So we have two interfaces, and let's say this is print1 and this is print2. Okay, so we have two interfaces, iCustomer1, iCustomer2. And let's say iCustomer2 actually inherits from iCustomer1. And then let's say our customer class inherits from iCustomer2. So customer2 inherits from customer1, and this customer class inherits from this. So obviously print1 and print2 is available to the customer class. Now look at this. Our customer class here is actually inheriting from iCustomer2. So we need to provide implementation for print2 method. So we can say public void print2. And then let's say console.writeLine print2. So now if we go ahead and compile, it will not compile. We'll get a compiler error. Why? Because this customer class is inheriting from iCustomer2. So iCustomer2 has got this method. So we have provided the implementation for that method. But iCustomer2 is inheriting from iCustomer1, and iCustomer1 has got print1. So print1 is available to iCustomer2 as well. And since customer is inheriting from I customer 2 has got now print1 and print2 to implement. So if an interface inherits other interfaces and your class inherits from this interface, then this class has to provide implementation for this member, this member. And if you look at this, this is an interface inheritance chain. Okay, and this class is inheriting from this interface in that inheritance chain. So this class has to provide implementation for all the interface members in this interface inheritance chain. Okay, so if a class inherits an interface and if that interface inherits another interface, then your class has to provide implementation for all the members in that interface inheritance chain. Otherwise, we get a compiler error again. So let's go ahead and try to build this and see what we get. So it says that iCustomer1.print1 is not implemented by this customer class. So obviously we have to implement that as well. So just make a copy of that. We can say print1 and print1. So now this customer class is implementing both of these methods. And now we try to build that, the build succeeds. Okay, look at that, build succeeded. Now let's go ahead and see how to use that. So I can go ahead and create a customer object. Customer C1 is equal to new customer, and you can call both C1.print1 and C1.print2. And you go ahead and run that, you get print1 and print2 as expected. Okay, this is another important point. Okay, probably this is what we will use in a real-time scenario. We cannot create an instance of an interface, but an interface reference variable can point to a derived class object. And look at this, we don't really have to mug these statements. They make a lot of sense. We cannot create an instance of an interface, and that makes sense. Let's say, for example, if I am able to create an instance of an interface, for example, we have this iCustomer1. Let us say cust is equal to, when I say new iCustomer1, now look at this. If I am able to create an instance of this interface, an object of this interface, and this interface has got this print1 method, is that print1 method implemented? No. So when I call this customer interface object 1 dot print1, what will it do? Since there is no implementation, it cannot do anything. That's why it does not allow us to create an instance of an interface. Basically, interfaces are incomplete. Okay, because they don't have implementations. If you create objects and if you're able to use them, they cannot do anything. That's why the language doesn't allow us to create instances of interfaces and abstract classes as well, which we'll be talking about in a later session. Okay, so you cannot create an instance, an object, you cannot new up an interface. But what you can do is, in the last session, we have actually spoken about the difference between an object reference variable and the object itself. Okay, if I say customer C1 is equal to new customer, C1 is actually an object reference variable to an object on the heap. Similarly, here cust is a reference variable of type iCustomer1. But what you can do here is you can say new customer. Okay, now customer class is actually inheriting from that interface. Customer is inheriting from iCustomer2 and iCustomer2 is inheriting from iCustomer1, which means for customer, iCustomer1 is also a parent. Okay, and in the inheritance, in class inheritance chapter, we have learned that a parent class reference variable can point to a child class object. Similarly, since an interface since this iCustomer1 is a parent to a customer class, a reference variable of iCustomer1 can actually point to customer object. That's why we are able to do this. iCustomer cust is equal to new customer. Now when I say cust dot, I will only see the print1 method. Because why? iCustomer1 is of type, cust is of type iCustomer1. Okay, so that's another important concept to keep in mind. Very, very important. So we cannot create an instance of an interface, but an interface reference variable can point to a derived class object. And we have already seen that interfaces names are generally prefixed with capital I. As I told you, in the next session, we will actually be talking about abstract classes and the differences between interfaces and abstract classes, after which we will see the real-time application of these abstract classes and interfaces. On this slide, you can find resources for ASP.NET and C# interview questions. Thank you for listening. Have a great day.